Hello everyone. We're here today to learn the tasks of generator, excitation control system. I am today's main teacher, Luo Qiang. The excitation control system of the generator plays a very important role in the normal or accidental operation of the power system. An excellent excitation control system can not only ensure the reliable operation of the generator, provide qualified power, but also effectively improve the technical indicators of the system. According to the operational requirements, the excitation control system should undertake the following tasks. Voltage control, control the distribution of reactive power, improve the stability of parallel operation of synchronous generators, improve the operating conditions of the power system to meet the requirements of the hydro generator units to forcibly reduce excitation. The function of the modern excitation system of synchronous generator. First, adjust the terminal voltage of generator output before the generator is connected to the grid. Second, regulate the reactive power borne by the generator after the generator is connected to the grid. Third, improve the static and dynamic stability of synchronous generator, parallel operation. 3.1 Static steady. Using a sensitive and fast excitation regulation system can improve generator stability in small disturbances. Static steady. 3.2 Dynamic steady. Using a fast response excitation regulation system with a high top voltage can improve the generator stability under large disturbances. Dynamic steady. Transient steady. Fourth, in case of generator accident, rapidly demagnetize the rotor winding to protect the generator. First, let's talk about voltage control. When the power system is in normal operation, the load always fluctuates frequently and the power of the synchronous generator changes accordingly. As the load fluctuates, the excitation current needs to be regulated to maintain the voltage at an extreme or point in the system at a given level. The automatic excitation control system has the task of maintaining the voltage level in order to illustrate its basic concepts. We can analyze it with the simplest single generator operating systems. This is a schematic diagram of a synchronous generator. In the diagram, GEW is the exciting winding. The extreme voltage is UG, Faster, and the current is IG, faster. Under normal circumstances, the excitation current flowing through the exciting winding GM for IEF, the magnetic field established by it so that the stator generated by the low-load induction potential for the EQ faster change the magnitude of the IEF. The EQ phasor value will be changed accordingly. The relationship between the EQ phasor and UZ phasor can be represented by an equivalent circuit diagram. The relationship is shown in the equation, where XD is the generator direct axis reactance. The phasor relationship is shown in the figure. The relationship between the phasor of generator induced potential EQ and the phasor of terminal voltage UZ is shown in EQ. The delta is the phase difference between EQ and UZ, that is, the power angle of the generator. IG is the reactive current of the generator. Generally, the delta value is very small, can be approximated that the cos delta is approximately equal to 1. So you can get a simplified arithmetic formula is the equation shows that the reactive current in the load is the main cause of the amplitude difference between EQ and UG. The larger the reactive current of the generator, the larger the difference between the two. From the diagram, we can see that the external characteristics of the synchronous generator must be decreasing. When the excitation current IEF is certain, the generator terminal voltage UG decreases with the increase of the reactive load. The figure illustrates that when the reactive current is IQ1, the generator terminal voltage is rated value UGE. The excitation current is IEF1 when the reactive current increases to IQ2. If the excitation current does not increase, then the terminal voltage drops to UG2, which may not meet the operating requirements. We must increase the excitation current to IEF2 to maintain the terminal voltage for the rated value UGE. Similarly, when the reactive current decreases, the UG rises and the excitation current must be reduced. The excitation automatic control system of synchronous generator is to maintain the machine voltage at a given level by continuously adjusting the excitation current. The second aspect is to control the distribution of reactive power. Since the active power from the generator is only controlled by the governor and has no relation to the magnitude of the excitation current, because the generator terminal voltage UG is a setting value. So the only change in the generator excitation current is the change in the reactive power of the unit, and the magnitude of the power angle delta value. To make the analysis simple, suppose the synchronous generator is in parallel operation with an infinite bus. That is, the generator terminal voltage does not change with the load magnitude and is a constant value, as shown in the figure. Since the active power from the generator is controlled only by the governor, which is not related to the magnitude of the excitation current, no matter how the excitation current changes, the active power PG of the generator is a constant. That is, as shown in the formula, where FA is the power factor angle, when the stator resistance and the convex machine effect are not considered. The generator power can be expressed as PG is equal to EQ, multiplied by UG divided by XD, multiplied by sin delta equals to the constant, where delta is the power angle of the generator. The above two equations respectively show that when the excitation current is changed, the values of IGCOS, FA, and EQSIN delta are kept constant, and then the endpoints of the induced electromotive force EQ factor can only be varied along the dashed line AA. When the endpoints of the generator current IG factor are varied along the dashed line BB, because the generator terminal voltage UG factor is a constant value. The change of the generator excitation current only changes the magnitude of the unit's reactive power and power angle delta value. This shows that regulating the excitation current of a unit operating in paralleling with an infinite bus can change the value of the reactive power of the generator. In actual operation, the bus operating in parallel with the generator is not an infinite bus. That is, the system equivalent impedance is not equal to zero, and its voltage will change with the load fluctuations. Changing the excitation current of one of the generators will not only affect its voltage and reactive power, but will also affect the reactive power of the units operating in parallel with it. The degree of fluence is related to the system situation. Therefore, The synchronous generator excitation automatic control system is also responsible for the reasonable distribution of reactive power between parallel operation units. That's all for this lesson. Thank you.